class we have seen on NFA to TFA conversion. Now we are going to see Epsilon NFA, and then we are going to convert that Epsilon NFA to NFA. So first, for that we will see what is Epsilon NFA. So what is Epsilon NFA is whenever the state, any state is triggering to the other state, it is doing a transition with the other state without an input. So with we have seen with an input like A, B, C, 0, 1. So if there is without an input it is triggering, and in that place we will be having an epsilon. Then it is said to be as an Epsilon NFA. Other than that, it is everything is same. So we already seen what is NFA. So NFA will have what? Delta transition. So delta transition equal to what? Q into summation, you will get 2 power of Q. Whereas in Epsilon NFA, we will get delta transition equal to Q into epsilon union of what? This summation union of epsilon. So this will give 2 power of Q. Okay, so this is the difference between NFA and Epsilon NFA. Okay, so simply we are adding epsilon also as an input here. Okay, so now we are going to convert this Epsilon NFA to a normal NFA. So for that, what and all these steps you need to follow is, first you need to find epsilon closure, then you need to extension of this transition function. So you need to extend the transition function. So you need to extend that. Then third thing, you need to finalize the final states. Okay, these are the 3 steps we are going to follow. So for that, first we'll see what is epsilon closure. So what is epsilon closure is, so you are having a state like Q1, then Q2, then Q3. You are having, these are the 3 states you are having now. So in this, epsilon is here, and then here we don't have an epsilon, here also we don't have an epsilon. So if I am writing epsilon closure of Q1, so wherever the epsilon path is going from Q1, you will take all the path till its destination. So now Q1, it is starting with epsilon and it is ending with Q2. So you will take Q1 comma Q2, and epsilon closure of this Q2, you will take only Q2 because there is no epsilon transition from Q2 itself. So you will take only the self transition Q2 alone. And then epsilon closure of Q3 will take only Q3 because we don't have an epsilon transition in Q3. Suppose for example, here also epsilon is there. Then how the path is moving Q1 to Q2, the same epsilon transition it is moving to Q2 to Q3 also. Then here it will change. The Q1 epsilon closure will be Q1 comma Q2 comma Q3. Now the Q2 will be Q2 comma Q3. Q2 comma Q3. Now Q3 will be, only Q3 will be there because there is no epsilon transition here. Okay, this is how you will be finding the epsilon closure. So next is extended transition. So how you will do the extended transition? Extended transition you will be using a formula. So normally you will have delta transition, right? So same like that, you will be framing a new transition delta dash of Q comma X. So what is this? Q is a state, X is a input. So you will need to do epsilon closure of, okay, del dash of Q comma X, sorry, Q comma epsilon comma X. So what this X is a input and Q is a state. So here del dash. So now you want to know the value of this, right? So what will be the value of del dash of Q comma epsilon is epsilon closure of this state Q. So these are the 2 formulas we are going to use it for extended transition function. Okay, this formula you need to memorize and this formula you need to memorize, where Q is a state and X is the input. And here whenever we are going to have a delta transition of q with an epsilon, we will get a epsilon closure of that same state. Okay, so for example, if del dash of q naught comma epsilon you are getting, then the output will be epsilon closure of q naught. Okay, so like this you will be framing the you will be substituting inside the formula and you will be framing the epsilon closures of the generated transition, the next generated transition, that is we are converting the epsilon NFA to NFA transition, we are converting it. So then at last you will be finalizing the final states, how many final states are repeated in the other epsilon closures, that you will be finalizing it. So now we will take one example and we will solve the conversion of epsilon NFA to NFA. So what we'll do is we'll take a transition q naught, then q1, then q2 will be the final state. Here I am taking A as an input, here epsilon as an input, here B as an input I am taking. Now you draw the transition table for this. So first delta, then input will be A, input will be B, then epsilon. Then delta will be q0, q1, q2. Okay, so now this q0 will be the initial state and q2 will be the final state here. And q0 A is q1, it is going. Okay, then q0 B, there is no transition, I am taking as null. q0 epsilon, there is no transition, I am taking as null. Then q1 A, it doesn't have a transition. q2 B doesn't have a transition. Then q2 epsilon, it has a transition to q2. q1 epsilon. Then q2 A doesn't have a transition. This q2 B has to q2 itself. Then epsilon doesn't have a transition. So now after this construction of transition table, we are moving to the epsilon closure. First we need to find the epsilon closure. Now what we'll do, epsilon closure, okay, epsilon closure of q naught. So what is the epsilon closure of q naught? There is no epsilon transition itself. So you will put directly q naught itself. Then epsilon closure of q1. So q1 has an epsilon transition. It is traversing to the path of till q2. So q1 comma q2. Okay. So next is we will have epsilon closure of q2. So that is you will have no epsilon transition itself. So we will take a self transition itself q2. Okay. So this is a epsilon closure. After finding the epsilon closure, what we are going to do is, okay, we are going to do the extended transition function. Extended transition function, already we know the formula, right? For in that we are going to substitute each and every state with different input, only A and B, because we are going to eliminate the epsilon there. So we need to eliminate the epsilon and we need to use only the A and B. So first what we'll take is delta dash of q naught comma A. So what you will write, epsilon closure of del dash of q naught comma epsilon comma A. Okay, now this q naught comma epsilon, what I said, del dash of q naught comma epsilon is again epsilon closure of that same state q naught. So what will happen, epsilon closure of del, this del dash will become like what it will become, epsilon closure of q naught it will become. So epsilon closure of q naught, then comma A. Now we know what is epsilon closure of q naught, we have found here. This what will happen, epsilon closure del of epsilon closure of q naught is q naught again. So q naught comma A. So now what is this q naught comma A? So epsilon closure q naught comma A is, here you just check, q1. So q1. Okay, q naught comma A is Q1. Now epsilon closure of Q1 is what? Q1 is Q1 comma Q2. So Q1 comma Q2 is the answer for this transition. Now you just substitute same for Q0 comma B. Next input I am taking. So now what will happen? Epsilon closure of del dash of Q0 comma epsilon comma B. So what will happen now? Epsilon closure del dash of Q0 comma epsilon is what? Epsilon closure of Q0 itself comma B. So now epsilon closure of Q0 is what? Q0 itself. So now epsilon closure del of Q0 comma B. Q0 comma B we have what? It's a null statement. So epsilon closure of null. So you will get what? Again you are going to get null itself. So same like this you need to do it for other states also, like Q1, Q2, everything you need to do it separately and you need to find the new states. So here we'll take the what? Here we'll take. So here we'll take the new states. This here equal to pi. Here we'll take the new states transition table. So first is delta input A, input B. So first state is Q0, it's the initial state, and then Q0 comma A, what we are getting? Q1 comma Q2 we are getting, and Q0 comma B we are getting 5. Okay, now I am taking Q1 comma A. You just replace Q0 with Q1. So wherever it's Q0, I am replacing with Q1. Now what will happen? Q1 comma epsilon is epsilon closure of Q1 it will happen. So epsilon closure of Q1. Now this epsilon closure of Q1 is what? Epsilon closure of Q1 is Q1 comma Q2. So now here it will become like Q1 comma Q2. Okay, Q1 comma Q2. Now you need to find Q1 comma A, union of Q2 comma A. So Q1 comma A is pi. Okay, then union of Q2 comma A, that also it's a pi. So Q1 comma A is also pi. Then Q2 comma A is also pi. So both union it will give pi again. So for example, like this it is. So if you have not understood, I'll write clearly. So like some delta of what will happen? Q1 comma A union of delta of Q2 comma A. So this also it's pi, union of this also it's a pi. So now answer will be pi. Okay, so here for Q1 transition this is pi. Now you are substituting Q1 with B, Q1B. So here also Q1. So now here epsilon closure of Q1 comma epsilon is Q1, again epsilon closure of Q1. Then again what you will do here, epsilon closure is Q1, epsilon closure of Q1 is again Q1 comma Q2. So now here it will become what? Q1 comma Q2. Now I'll take union Q1 comma B. Q1 comma B is pi. Then Q2 comma B is Q2. Now pi union Q2. Pi union Q2. Now what will happen here? Q2 will come. Q2 will come. Now epsilon closure of Q2 is Q2. So now here Q2 will come. Okay, are you clear? So now this Q2 will be here. Now third state is Q2. Q2 comma A. What will put Q2 comma A? Here also I will change as Q2. Okay. Then here epsilon closure of Q2. Then epsilon closure of q2 is q2 again. So here I'll be changing as q2 comma a. Then what is q2 comma a? q2 comma a is pi. q2 comma a is pi. So epsilon closure of pi will get, and again the answer is pi. So now q2 comma a is pi. So epsilon closure of pi is also pi. So I am getting pi answer. Now here q2 comma b. q2 comma b, here q2 comma epsilon. Then here also it will be like q2, again q2 comma epsilon is what? Epsilon closure of q2 comma b. Now epsilon q2, so the next is epsilon closure of q2 comma b we need to find. So epsilon closure of q2 comma b is what? So sorry, epsilon closure of q2 is again. So epsilon closure of q2 is q2. So q2 comma b. Okay, so now q2 comma b we have found. Now delta transition of q2 comma b. Delta transition of q2 comma b is q2 again. So now epsilon closure of q2. Epsilon closure of q2 is what? q2 again. So we will get an answer of q2. So here we will get q2. Okay, so for this is a newly framed transition table for an NFA. We have eliminated the epsilon here. So for this you need to draw the transition diagram. So first initially we had a transition diagram with epsilon. Now the for same this we are converted into an without an epsilon. So here what is the final state you will take in the epsilon closure? Q2 is the final state in a normal given epsilon NFA. So if this Q2 and Q2, it is coming in the epsilon closure of Q1 and Q2. So you will take the final state Q1 and Q2, both are final states here. Since the Q2 is coming in both the epsilon closures, we are taking the final state as both the states. Now you will draw the transition diagram. So first is Q0 as an initial state and Q2 as a final state and Q1 as a final state and Q2 also as a final state. Okay, now this Q0 is getting an input of A and doing the transition with Q1 and Q2. So this Q0 getting an input of A and doing the transition with Q1 as well as Q2. Okay, then now Q1 is doing a transition to Q2 by getting an input of B. So Q1 is doing a transition to Q2 by getting an input of B. And Q2 is doing a transition with Q2 by getting an input of B. Okay, now we have eliminated the epsilon and we have drawn the converted NFA, that is without an epsilon. I think you have understood this concept. So normally for converting this epsilon NFA to NFA, first step is you need to find the epsilon closure. Then you need to do the generate extended transition function. Then you need to find the final states by using this epsilon closure. Then you need to draw the transition diagram. Okay, so next class we will see about the minimization of DFA concepts. Okay, thank you.